These questions for the Leaving Cert foundation level could also be used as part of QQI levels 3 and 4. Come under the broad heading of number systems. So this question here, part A, asks us to write the following numbers in order, starting with the smallest. So we have 73%, 3/4, 0.7 and 4/5. So perhaps we could do it with trial and error, just inspecting them. But I think with questions like these, it's easier to convert decimals, fractions and percentages into a fraction with a similar denominator. So I think let's look at 73%. Well, that can be written as 73 over 100. 3/4 can be written as 75 over 100. 0.7 is 7 over 10, which is 70 over 100. And 4/5 can be written as 80 over 100. We can force 4/5 to be a fraction of 100, multiply top and bottom by 20, and that makes it 80 out of 100. So starting with the smallest then, so the smallest fraction is 70 out of 100. Next we have 73 over 100, 75 over 100, and 80 over 100. So to answer maybe the question in the best possible manner, so 0.7, 73%, 3/4, and 4/5. Part B. The population of India is estimated to be about 1,343,000,000 people. Write this number in the form A multiplied by 10 to the power of n, where A is greater than or equal to 1 but less than 10, and n is an integer. Now, that's essentially the maths way of saying this. So write this in standard form or scientific notation. So this can be written as 1.343. So A, remember, must be greater than or equal to 1 but less than 10. And to make that number then become 1,343,000,000, we need to multiply it by 10 9 times. Part 2. Mary is taking a trip to India and is texting a friend about the population of that country. Write the number 1,343,000,000 in words. So 1,343,000,000 It's a lot of people. 1,343,000,000. Part C. There are 60 people at a party. The ratio of adults to children is 1 to 5. How many adults are at the party? So ratios are essentially rational numbers or fractions. So 1 to 5 can be simplified as 1/6 to 5/6. So there are 1/6 adults. Remember, it's the ratio of adults to children. So the 1/6 constitutes the share of adults. 1/6 of 60 is equal to 10. So there are 10 adults at the party and 50 children. Next question. These are indices, so your rules of indices you will need to know. Part A asks us to write 125 as 5 to the nth power, where n is a natural number. So 125 is 5 to the third power, which, you know, just it's 5 times 5 times 5. So there's the answer here. Part 2. 49 raised to the half is another way of writing the square root of 49, which of course is a perfect square, which is equal to 7. Here, part B, we're asked to simplify a raised to the 4 all squared over a5. So, the numerator of this fraction can be simplified as a to the 8th power all over a to the 5, and here we subtract the indices, which is equal to a to the 8 minus 5, which is equal to a raised to the 3rd power. Let's move on. Now, the table below shows a list of numbers and a list of sets that a number could be an element of. Let's go through this. So the numbers are 3 minus 2 minus 0.5, the square root of 2, 2 2/3, the sine of 30, and pi. Now, so 3, let's look at 3. 3 is a natural number, it's a counting number. So the natural numbers are the counting numbers. It's also an integer because it's a whole number. It's also a rational number. Remember, a rational number is a fraction. 3 can be represented as 3 over 1. And it's also a real number because it can be on the number line. Minus 2. Minus 2 is not a natural number. It's not a counting number. However, it is an integer. It's a rational number because it can be expressed as a fraction, minus 2 over 1. And it's also a real number because it can be on the number line. Minus 0.5. Minus 0.5 is neither a natural number nor an integer. It's not a whole number, it's not a counting number. However, minus 1/2 is indeed a rational number, and it's also a real number. The square root of 2 is an irrational number, but it's a real number because it finds itself on the number line. 2 2/3 is essentially 8/3. It's a rational number and it's a real number. The sine of 30 is a half. So it's a rational number and a real number. Pi is an irrational number. It's a non-terminating decimal, 3.14, and goes on. So it can be placed on the number line, so it's a real number. Mark each of the numbers in the table below. Mark each of the numbers in the table above on the number line below and label each number clearly. So I'm just going to do some of these here now. I'll do some of the most difficult ones really. So let's look at sine 130. So sine 130 is 1/2. So 1/2 is halfway between 0 and 1. And when you see number lines like this, it's important to to be accurate about the intervals. So obviously there's 1, 2, 3, 4 intervals between each number. So that this is 1/4, 1/2, 3/4, and 1, and so on. So sine 30 is 1/2. So I can label that there. Sorry, let's just rub this out, tidy this up a bit. So sine 30 is 1/2. You can use your scientific calculator to work that out. So I'll mark that there as sine 30. Pi is 3.14. So this is 3.25 here. This is 3.5. So it's here. It's halfway between 3 and 3.25 approximately. So I'll just do it there and say pi. 2 2/3. Well, 2 2/3 is 2.66. There's 2.5 here. So there's 2.75. So you could say it's here. Okay. 2 2/3. So for a question like this, it's important that you know you're able to differentiate your natural numbers from your integers and your real numbers and so on. Now, this last question here, the average distance from the Earth to the Moon is 3.84 multiplied by 10 to the power of 5 kilometers. So again, this is a number written in standard form or scientific notation. So it's going to be 384 plus another 3 zeros, 1, 2, 3, which is 384,000 kilometers. Part 2. It took Apollo astronauts 3 days and 4 hours to travel to the Moon from the Earth. Find their average speed in kilometers per hour. So average speed, well, you know, when it comes to these distance, speed and time questions, I always recommend just writing this little triangle here to help you with the formulae. So we know then that average speed is distance over time. So average speed is equal to distance divided by time. So we know the distance is 384,000 kilometers, and always include the units of measurement. And the time taken was 3 days and 4 hours. Now, they want the average speed in kilometers per hour. So the easiest thing to do is to convert 3 days and 4 hours to hours. But 3 days is 72 hours, 3 times 24, plus another 4 hours, so that's 76 hours. So your answer is going to be in kilometers per hour. And if we take out our calculator and do that, it's 384,000 divided by 76, and we get 5,052.63 ... So to the nearest whole number, it's 5,053 kilometers per hour. So that's some questions there that come under the heading of number systems.